This is StarTalk Special Edition. Neil deGrasse Tyson, your personal astrophysicist. Chuck Nice over here.
What's up?
We've got Sean Carroll on the line. Sean, how you doing, man?
Hey, how's it going?
And so let's catch people up on your trajectory through life. You spent a lot of your professional career at Caltech over in Pasadena, and now you joined us back on the East Coast in Baltimore at the Johns Hopkins University.
That's right.
And I've got you as the Homeward Professor of Natural Philosophy.
That's right. There aren't that many of those. I'm basically the only one, so it's nice.
Right.
Yeah.
This is a very retro title.
It is.
Okay. I think Newton had a title of natural philosophy.
Right.
Before the word physics was a thing.
Yeah.
Yeah. And you're one of my favorite people out there because not only do you bring science to the public, which is something we care deeply about here at StarTalk, but you have for me, the best combination of astrophysics fluency,
Right.
physics fluency,
Right.
and philosophy fluency.
Right.
You put all that together, and there's no boring conversation you will ever have, ever. So, Sean, you had a couple of books recently. I mean, you're always out there, talking physics smack with an interested public. You have two in a row here: Space, Time, and Motion. That's what's left after that, right? Right.
That's a lot.
He's got quanta and fields.
What's left will be volume 3, which is complexity and emergence. That's what I'm nearly done with writing right now. So it's a whole 3-part series called The Biggest Ideas in the Universe. Yeah.
Fields is a thing
Right.
that if I didn't study physics, I'd still think they were kind of imaginary. You go back to Faraday, right, who says there's magnetism there, but there's a field. Well, can I see it? No. But the iron filings can see it, but I can't.
Right.
Okay. But if you take away the iron filings, is it still there? Yeah. And so what did it take to get everybody comfortable with the idea of a field?
That's a great question because it wasn't easy. It took a while. Isaac Newton worried about the fact that he didn't know about the concept of field. He said that there was a gravitational force between the sun and the earth, and it depends on the distance, the inverse square law. The bigger the distance, the less the force. But he didn't know how it got there. How does the earth know where the sun is, how far away it is, how massive it is? And he said, this is over my pay grade. I'm going to leave this for future generations to decide, which is not the kind of thing that Isaac Newton said very often. So it wasn't until the 1800s.
So he knew something was up.
He knew something was up.
That needed further explanation. Yeah.
Wow.
Action at a distance. Einstein famously said spooky action at a distance for quantum mechanics. But even in Newton's time, there was this weird thing. What is it that takes the gravitational force and moves it from the sun to the earth, et cetera?
And vice versa. Yeah.
And in some way, there was an answer there from Laplace, Pierre-Simon Laplace, but it wasn't until Faraday, like you said, that he starts moving magnets and watch electrical currents pop up in a wire next to it, like not there, not touching it, right? Through empty space, something happened. And the great thing about Faraday was he was an absolutely genius, intuitive physicist. He was not the math expert that you sometimes need to be. So James Clerk Maxwell came along, was a huge admirer of Faraday, and basically made it all mathematically respectable and said, yeah, there's these things called the electric field and the magnetic field, and they fill all of space and you can't see them, but we can predict what they're going to do, and they're super duper important for explaining everything.
I think Faraday, if memory serves, in none of his published papers does an equation of any kind appear.
That's possible. I didn't know quite that factoid, but it's absolutely in keeping. Yeah. He was thinking about, in fact, it wasn't even fields that he primarily focused on. He imagined lines of force. So like out of an electron, there's an electric field, we would say now, but he thought they were like literally lines of force filling all of space. And Maxwell's first papers were about trying to make mathematical sense of lines of force. And he eventually said, nah, it's better to think of fields with little vectors, so like little arrows at every point, and then the lines are sort of moving in the direction of the arrows.
And that all happened in the 19th century.
All happened in the 19th century. Yeah. And the great thing was, if you think of the number of different apparent phenomena in the world that we now think of as electricity and magnetism in action, right? Heat, light, radio waves, X-rays, the magnets, all this stuff, like very, very different things, all explained in just two fields talking to each other, electricity and magnetism.
That's amazing.
That's completely crazy.
It's just crazy.
And I was just thinking, I go through this sort of existential moment maybe once a month. I'm sitting there and I press a button on my smartphone and it changes the channel on my TV.
Right.
And then I press another button, it starts my car,
Right.
which is 3 miles away.
Yeah.
And I'm thinking, this is magic.
Yeah, and this is why writing books is good, because you write a book and you say, like, you point your remote control at your TV and a radio wave comes out and turns it on, and you get many emails saying that's an infrared wave, not a radio wave, but they're all different manifestations of electromagnetism. And so
wait, but my cell phone is not
your cell phone
infrared.
is not, but your TV remote control is.
Yeah, that's for
Right.
sure.
Yeah.
Mm-hmm.
Yeah, exactly. Like who knows these things? I can't keep track of these things. I'm just a theoretical physicist.
It's funny, while you guys are talking, I'm sitting here with my iPad and I'm taking my finger and moving the screen up and down. Isn't that the electromagnetic field on my finger?
Basically, everything is the electromagnetic field. Yeah, other than gravity, it's all electromagnetism all the way down.
Yeah, we live it.
We just live it.
There's a hugely important philosophy of science lesson here, because like Neil said, you can't see the electric field or the magnetic field, but they're clearly everywhere. Like, we have equations that describe them exactly and make predictions and fit all the data. Therefore, we accept that they are there. You don't need to see them with your eyes to have evidence that they're part of reality.
I try to beat that into Chuck every time when I say the universe is
under no obligation
to make sense to you. What's this latest paper we have you publish here, co-authored, what Hawking radiation looks like as you fall into a black hole? Was that something that needed to be addressed?
It's something that I've worried about for decades. And honestly...
Really?
Yeah. Well, so here's the question. There's two things that we think are true about a black hole. One is, if you're standing very far away and you look at the black hole, Stephen Hawking says black holes give off radiation. Okay? That he, again, has an equation that predicts exactly how much you should see. The second thing is, we have this feeling, no one's ever done it, that if you fall into a black hole, you see nothing special when you cross the boundary, when you cross the event horizon, right? It just looks like ordinary empty space everywhere. But these two statements seem a little bit contradictory, because if I'm standing far away and I see radiation coming out, and then I just fall in, right? I stop, my rocket ship or whatever, and I let myself fall in. Neil, that you should see that redshift, that radiation get blue shifted. It should look brighter and brighter and more energetic. So why does it turn off when you hit the event horizon? What actually happens? What is it that you see? And it turns out this is 100%, implicit in all the equations that we have, but it took a lot of work to actually pull it out. And the answer, in a very short, slightly oversimplified form, is there is high intensity radiation when you're crossing the event horizon, but you're moving so fast that you don't have time to observe it. So it looks to you like there's nothing there.
I mean, in a Heisenberg uncertainty principle way, you don't have time to observe it.
Yeah, exactly right. And by the way, before I forget, I got to give huge credit to Chris Chaloux, my co-author on this.
Your co-author, yes.
He was a grad student at Harvard who just graduated, did all the heavy lifting on this and other projects, and he was fantastic. So he got the right answer after other people's got it wrong.
In physics and astronomy, in our journals, it is not our tradition to put our degrees after our name, the way it is in the social sciences.
And why is that?
Well, I made up a reason why that's good, but I don't know if it have different origins. And Sean, you might have some insight here. If you didn't otherwise know the people, you have no idea who is senior, who is junior, because a brilliant idea can come out of anybody.
Gotcha.
Even your students.
Right.
And so there's no reason to segregate who's got title and who doesn't, because a brilliant idea is a brilliant idea no matter the package, and a stupid idea is a stupid idea.
True. No matter who comes up with it. Yeah. I like that. I like that
it's
system.
It's very egalitarian.
Yeah.
I like that. One other thing before we get to our Patreon questions, something that's fascinated me for decades, ever since I could think about this question. and that's the arrow of time. Some of my earliest books in middle school were all about time and how it passes, and why do we know time is going forward rather than backwards. And you have some emergent thinking on that?
I absolutely do. This is something that was hugely important for me in my career. The arrow of time is just the fact that the past and future are different from each other, right? Like I can have photographs of the past. I cannot have photographs that are truly representing what happens in the future. So, why is this true? And Aristotle wouldn't even have had the question. Like they're just different things. Like why is an elephant not an orange? Like what are you even asking? But once Isaac Newton comes along with his theory of physics, suddenly the distinction between the past and future disappears. Like these equations don't treat the past and future differently. So it turns out, long story short, that it's a cosmology question. The early universe, 14 billion years ago, near the Big Bang, was in a very special organized state. And it's becoming more disorganized and higher entropy, as we say, ever since then. That's where the arrow of time comes from. But okay, why was the early universe like that? And that we don't know. I wrote a paper about this 20 years ago, and I'm revisiting that now to try to improve upon it. We still don't know, but I do think we're making progress in that direction.
We know which direction time moves because certain phenomena we would never see in reverse. Like some famous ones are you drop a blob of ink in water, the ink will disperse. You never see that happen in reverse.
In reverse.
Right. So if you're just eavesdropping on a scene, and no one told you which way time was pointing, just by phenomena that occur, you should be able to know. You should be able to figure it out.
Yeah. Like you never see an orange fall up from the ground back onto a branch.
Right.
But these are, you're picking good examples, but let's admit you're picking the easy examples. We understand those examples, but I can make a choice about what to do right now. Like I could make a choice right now. This is the most boring podcast ever. I'm going to storm off and not do it. But I can't make a choice now not to have come on the podcast in the first place. I can't make a choice that affects the past.
Oh, look at that.
And so that's right there at the boundary of physics and philosophy. Both the physicists and the philosophers need to think about this. And again, we have good ideas, but there's still work to be done.
Wow. And now you got me thinking about the multiple timelines and parallel universes and every single, like if we are on call it a trajectory, every choice that we make, all those other possible trajectories from this point of decision still continue forward just without me.
I'm not sure if I'm quite on board with your explanation there.
What I'm saying is the possibilities of all those trajectories.
Well, there's the many worlds hypothesis.
Is that what that is?
I think that's what you're describing.
Is that what I'm talking about? Okay.
Well, it's pretty close. I mean, many worlds is like really down to earth and equation based. There's the Schrodinger equation of quantum mechanics tells you what set of things happen in the future and which don't. And it's not because you're making a decision that creates a difference between one world and another. It's because of entanglement in the underlying quantum structure of reality. But we do have reason to believe that there are other copies of the universe where things turned out a little bit different. You can if you have an iPhone, you can download an app called Universe Splitter. And I'm a big salesman for this app here. And I don't get any commission or anything, but I think everyone should get it because when you're torn between two decisions, should I take this job or should I, just continue living a life of leisure? You can ask the phone and it will, you can plug in these two options and it will send a photon down a beam splitter that has a 50-50 chance of saying you should take the job or you should just stay sitting around. And then there'll be, if you obey the instructions, there will be a world in which you did the other thing.
That brings me to my question. All right, Sean, this is specifically for you, okay? This question. All right.
And it's your question.
It's my question. First of all, you have to be familiar with this experiment. In the double-slit delayed choice quantum eraser experiment. So it appears that the photons know they're being measured. Like they actually know. All right. So the signal photons and the idler photons show a constructive wave interference pattern when they're not measured by a detector. But there's 4 detectors and they can't know because of the way the detectors are set up because the photons are split and some go on not to be measured, and some go on to be measured. Okay? Now, here's the deal. There is no wave interference pattern when they are measured. So this makes it look like they know when they're being observed. I can understand the whole explanation of entanglement. I don't know why. I should say I can accept it. I don't know why it's easy for me to accept that, but I can just accept it. What I can't know or understand is a particle knowing that it's being watched. So are there any hypotheses that would explain why this thing would know?
Wait. So that's just your query there sounds like you just need the double slit experiment.
No, this is beyond the double slit experiment. Because, well, maybe I'll let Sean explain it, because I can explain it, but I'm probably not going to explain it as eloquently as Sean, the way the experiment is set up.
It's the double slit experiment is, of course, a famous thought experiment originally. They wrote down what it should do long before they ever did it to illustrate the magic of quantum mechanics. You have a single electron going through two slits. It's detected somewhere on the other side. And it's just a dot. You can't figure out that much from the dot. But you do that many, many, many times, and what you see is an interference pattern. It's like a wave went through the two slits, and waves go up and down depending on how far away they are from the target. And so a wave going through one slit can interfere with the wave going through the other slit, and that's what you see in the distribution of dots on the detector screen. So the miracle occurs when you observe which slit the electron goes through, right? Because in the Copenhagen usual way of thinking about quantum mechanics, when you observe the electron, you collapse its wave function. It's no longer going through both slits. You saw it go through one or the other. And magically, the interference pattern goes away because indeed you changed the electron dramatically by observing which one it goes through. So that's all standard stuff. Everyone, and their mom learns that in kindergarten when they're learning about quantum mechanics. The delayed choice quantum eraser experiment is a hilariously convoluted elaboration of that, which makes people feel bad for no good reason at all. I actually wrote a blog post about it called The Notorious Delayed Choice Quantum Eraser, where I make fun of people who are trying to make you lose sleep because of this. We're all victims here, I think. So the way that works is rather than just observe whether the electron goes through the left slit or the right slit, what do you mean by observe? You mean like maybe you with your eyeball or with some measuring apparatus have detected it. But what if you just entangle it a little bit? Like you entangle it with one little particle, okay? Then, unlike if you personally had observed it, you could imagine unentangling it. You could imagine not letting it get the interference pattern destroyed, or you could imagine having it be destroyed. And you can make that decision after the electron's been detected. That's the slightly spooky part, right? If you were the kind of person who spoke a language of the electron goes through one slit or the other slit and it's making a decision, then what Chuck says, like it sounds like the electron's decision was affected by what I did after it was detected. Oh my God, how could that be? But if you just talk the language of a wave going through and becoming entangled and taking quantum mechanics seriously, all of this is 100% what is predicted by the Schrodinger equation of quantum mechanics without anything knowing anything making any choices, or anything going backward in time. It's hard to explain, but I encourage people to Google Notorious Delayed Choice Quantum Eraser, and they will find my blog post, and they will hear it all. And this is literally the chapter I wrote for my book, Something Deeply Hidden, which is all about quantum mechanics. And I read the chapter and said, this is too much. Like, they don't need this. Like, this is too complicated and specific. So I just made it a blog post instead.
Excellent. And where do we find that blog post?
On my blog, preposterousuniverse.com/blog. But again, if you just Google Delayed Choice Quantum Eraser with the word notorious in front, my blog post will come up first, I promise you. It's a perfect example of rather than trying to demystify quantum mechanics, sometimes people try to mystify it. They try to make it sound even more confusing than it is.
Even more.
Quantum mechanics really is confusing. You don't need to make it sound more confusing.
Well, that's cool, man. Well, I appreciate that. Okay, here we go. This is from our buddy, Kevin the Sommelier. And he says, if dark matter were a wine varietal, would we be at the I know it exists, but I can't quite describe it stage, or the I swear I taste something, but everyone thinks I'm making it up stage? On a more grounded note for the holidays, Gaia Promise, which is a beautiful super Tuscan, will pair incredibly well with any roast that you are planning.
Oh.
And you're familiar with this Gaia Promise.
It's
huh?
expensive, but it's good. So in that question, I guess he's trying to, using his wine expertise, trying to probe what's really going on with the dark energy, or both?
No, he said dark matter.
Just dark matter.
Yeah.
Yeah. Could you just put some anchoring onto, because a lot of people think we're just making it up.
Yeah, making it up.
Yeah.
And does it have to be a particle?
Ooh, that's a tougher one. You made it tough. I had an easy question. Look, back in my day, when Neil and I were young, it was perfectly okay to think that maybe dark matter didn't exist. In other words, there were absolutely things going on in galaxies and clusters of galaxies, things like that looked like dark matter, looked like there's more matter in a galaxy than we could account for just by counting the stars and the gas and the dust. But maybe there was something weird going on with gravity. Maybe Isaac Newton and Albert Einstein didn't have the last word. We've long since passed that phase of the development of cosmology. And I think a lot of people haven't caught up because we've learned so much more from the leftover radiation from the Big Bang, the cosmic microwave background, from gravitational lensing with clusters of galaxies, from the growth of structure of galaxies and clusters and things like that. Dark matter exists. It's really there in some form or another. Now, maybe gravity's also modified. That's perfectly okay. But yeah, there's something called dark matter. Is it a particle? Well, we got to admit, we don't know what it is. The range of possibilities goes from, some tiny fraction of the mass of an electron to the mass of the moon or something like that, right? I mean, there's a very, very large range of possible masses that dark matter could have if it's a particle. Could it be something beyond a particle? It always could be. Like this, anything is possible. But boy, it really acts like particle-like. Like we know a lot about where the dark matter is, how much of it there is, how fast it's moving. It looks exactly like some massive, slowly moving particle that was sort of still stationary in the early universe and started moving ever since then. So it's our job to go actually find it. Then we'll know.
So 2 small points. I, whenever given the occasion, I don't describe it as dark matter because we don't know it's matter, but it is definitely dark gravity. That's what it is, right? Because we're tracking gravity at every turn that we say we're measuring the dark matter. So I think that's the most honest way to describe it. Because Sean, you've seen this. They're clickbait. There's a news article that says, scientists may be wrong about dark matter.
Of course.
It might not be
God.
matter.
Yeah.
But you're right. But we can't be wrong about dark gravity because we don't know what it is. Right. I'm just trying to distinguish that.
No, I think that's a perfectly good and fair distinction. But I think that I would just be more conclusive about what we do know. Like I said.
And you sounded very good there.
In the 80s, what we were discovering was there's more gravity at the edges of galaxies than there is that you would predict from the stars, et cetera, inside. So, okay, maybe gravity is different. But nowadays, we see gravity where there is no ordinary matter to cause it.
Okay.
So it's not just that the strength of gravity is different, but it's just pointing at something which we're not seeing. So that's dark matter.
You said a moment ago that we might one day need to modify gravity, but that's not what we need to do to explain dark matter.
It is not sufficient to explain dark matter. We
Very important.
need extra stuff out there. And just to be super duper clear, because again, much like the notorious delayed choice quantum eraser experiment, sometimes people like to make things harder to understand rather than easier to understand. There are people who have theories of modified gravity where they've changed Einstein's theory of gravity and they say, I can explain away the dark matter. But when you look at their theory of gravity, in addition to changing gravity, they've also put new sources of gravity in there, which are just dark matter.
This is Rachel Ambrose. And Rachel says, hey, Rachel here from Austin, Texas. I'm a big fan of Sean and his Mindscape podcast. Rachel says, I've been thinking about the spinning universe hypothesis. which says the entire universe may be rotating very slowly as a whole. This was hypothesized to help resolve the Hubble tension. But I was thinking, if it's true, could this also help us explain dark energy as a kind of centrifugal force, or centrifugal, depending upon how you want to say it?
Yeah, look, I'll be super honest, and my honest answer is I don't know. That sounds like a research program. Rachel should write a paper about this and submit it to the Physical Review. I doubt it is the slightly longer answer, because if the universe is rotating, then that tends to break the isotropy of the universe.
Okay, God bless you for that.
I'm gonna fill you in. Isotropy just means things look the same in every direction.
Okay.
Statistically
the same.
Not exactly the same.
Of course.
That's right. So there's not like a big hot spot in one side of the universe and cold spot on the other side. It's more or less the same average everywhere with little fluctuations around it.
And we have that right now.
That's exactly what we have.
Yes.
And so once you start messing with that, can you mess with it like just a little bit and maybe no one has noticed yet? Sure, you absolutely always can. But it's hard to do that. And the theory that we have for dark energy with Einstein's cosmological constant just does a really good job at fitting the data in a sort of a simple, direct, blatant kind of here I go kind of way. So I'm absolutely open to creative new things like the rotation of the universe, but where would that come from? I'm not sure. And what other effects would it have on observable quantities? I'm also not sure. So that sounds like a work.
All right.
Okay. Very cool. Well,
Plus, I think we still need verification that net angular momentum is manifest everywhere. I think it was just one pocket of the universe where they made this measurement. And so you would need to do more of the universe to reveal this,
right?
If it's really true. So it's which way spiral galaxies are rotating.
Right.
Yeah.
If there's a net rotation in one direction over here, that says there's something going on in the whole universe.
Gotcha.
Right. Because these galaxies wouldn't know about each other necessarily.
Exactly.
There's something in
so
the,
they
in
would
the birth
they're
sac.
responding to the same thing if that's
Exactly.
the case.
Correct.
I got you.
Correct.
Okay.
By the way, there's just to so people know that you got to be careful about these things. There was one study that had the brilliant idea. It was a while back, so we didn't have the computers weren't there. They had volunteers. It was like citizen science. They said, here are some pictures of spiral galaxies. You go through them, you citizen scientists, and tell us, are they counterclockwise spirals or are they clockwise spirals? Okay. And you would expect it to be 50-50, but it was like 70-30. Like there were a lot more clockwise spirals than counterclockwise spirals. And astronomers were like, oh my God, what is going on? And someone had the brilliant idea. Okay, let's give the same galaxies to the same people, but let's take the mirror image of them. Let's flip them. And guess what? It was still 70% clockwise galaxies. People were seeing things. People are not unobjective.
Get people out of the equation at all times.
Yeah, there you go.
You just got to be careful about all of these things.
Sean Browning says, hello, this is Sean Browning from Hood River, Oregon. In a previous episode, Neil stated that if you were to fall into a black hole, that would see the future of the universe unfold, or you would see the future of the universe unfold.
Behind you.
Right.
Yeah.
If that's true, then what would happen if the black hole finished evaporating before the universe ended?
So I think that the details matter here. There's a way that we have of thinking about black holes that is sort of idealized. Like I wrote a textbook on general relativity and you can learn about black holes in there, but the real world black holes are messy and, they're made of stuff and things like that. So I don't actually think it's true that you see an enormous amount of the past of the universe in a real black hole. In a real black hole, you would, as you know, get spaghettified and die. Yeah. If you're in a real evaporating black hole, you would first get spaghettified and then you would be released as a stream of black body radiation, and none of you is experiencing anything here. So I think that you don't need to worry. Like you would see more maybe than you would if you were outside the black hole, but there's no apparent paradox that you're going to see the whole thing.
But if the point is, if your time is slowing down as you near the black hole, then the time for the rest of the universe is speeding up. Right. I mean, you're normal and the rest of the universe is speeding up. Right. So I think that's the foundation of this question.
That is.
However long it takes you to fall into the black hole, will the universe, or vice versa, will one of them live out their days before the other one finishes what it's doing.
I think you should always think about, I mean, what I would like is that everyone in the world thought about space-time diagrams and light cones. You know, your past light cone, which is the set of all things that can send light signals to you without moving faster than the speed of light. It never covers the whole universe. It never sees the future. It never sees things that are further away from you than the speed of light can get. That's true whether you're inside a black hole or not. So there's some quantitative question about how much you see, but there's no worry you're seeing things that didn't happen yet before the black hole evaporated.
Hi, this is Dominic from Madison, Wisconsin. If you could instantly know the answer to one currently unsolved physics problem, no strings attached, which one would you pick and why?
I mean, the cheating answer is yes, tell me the theory of everything. Then I could work out everything else from that.
Let me double up behind you. What gives you the confidence that a theory of everything even exists?
Because the universe exists.
No, I'm not accepting that. It could be that quantum physics and general relativity in this universe never come together, and there's nothing that would ever bring them together. That's just how the universe is. We're invoking a philosophical bias of beauty to even assert that there is one theory of everything.
Nope, that's not true. The universe exists. There is something that happens, right? We don't know the best way of summarizing what happens. The best way of summarizing what happens in the universe might just be to literally list everything that happens. That would be a terribly uninformative theory of the world. We think we can do much better than that. I'm not saying that the theory of everything is simple or elegant or fits on a napkin or a t-shirt or anything like that, but there is some full and complete description of the universe.
The fact that you said it could be a very long account of everything that happens, but if it's everything that happens, then that's
everything that happens.
Then that's everything that happens.
Yeah, okay.
So that could be just a really messy, ugly, not philosophically beautiful theory of everything.
I'm very much in agreement with the philosophy that we should not be going around telling the universe how to behave. Like, we can't decide ahead of time what the universe is like. It's absolutely possible that the ultimate explanations are not that simple. I actually don't believe that. I think the ultimate explanation probably will be really, really simple, but I don't know. Yeah.
What if you can't access that information? Like, it is non-accessible on this plane of existence, but the answer is there.
Do you think that we have sufficient intellect to even get there?
Yes. I mean, again, we don't know, but what I like to do is just think about how far we've already come. You know, 100 years ago, we had just finished getting quantum mechanics. We didn't know about the expansion of the universe. We certainly didn't know about quantum fields and the standard model and all these things. And
we didn't know about other galaxies yet. It happened in 1926.
Holy moly.
Yeah.
Of course, it's possible we'll never get there, but the rate at which we've been learning things, and this is just the past 100 years. Think about the past 1,000 years, and 10,000 years from now, we're going to know a lot.
One of the hypotheses that I thought was intriguing was that as we measure the limits of whatever the limits are of what we're measuring, we might reach a cutoff, like in a Truman Show example, where he goes to the horizon, but the horizon is a painted sky. So we look at like the energy levels of gamma rays, or we find a cutoff that would have no natural explanation other than that somebody programmed this and they had to put in a limit because they couldn't put infinity into their software.
Yeah. Yeah. No, so I think it's fascinating to imagine at a slightly more detailed, careful level, what are the ways that we could become convinced that we're not ever going to find a simple theory of everying.
That's another way to think about it.
And things like that are, maybe we get evidence that we live in a simulation, or that the laws of physics are different from place to place and time to time. And so even if we get them figured out here, we won't know them some other way. But again, what's amazing to me is how rock solid and reliable the laws of physics are. Like, we're able to extrapolate them way past the environments in which we invent them, and they still work. I just got to put one example on the table, which is Big Bang nucleosynthesis. This is my favorite example of exactly this. A bunch of scientists, mostly in the 20th century, figured out the rules of nuclear physics, the rules of gravity, the rules of cosmology, and they realized the universe is 14 billion years old, and they extrapolate these rules back to when the universe was 1 minute old. And they make a prediction for how much hydrogen and helium they should be, and they got it right. We can figure this stuff out.
Fantastic.
And there's an example I got from Rich Gott. George Gamow makes a prediction based on this early nucleosynthesis of the universe that there should be a residual temperature of the universe.
And that would be the temperature pretty much. Not pretty much. That would be the temperature everywhere.
Everywhere. So think of the level of extrapolation this required. And he said the temperature would be 10 degrees. Okay. So then we finally measure it. It's 3 degrees. That's like predicting that a 10-foot flying saucer would land on the lawn of the White House, but it was a 3-foot flying saucer.
All right. Regarding the many worlds interpretation, is it simply a mathematical framework we use to describe quantum behavior and apparent wave function collapse? Or do you think it represents an actual physical process in which the universe truly branches into separate real worlds?
Yeah, how real are these other world
these many
hypotheses?
worlds?
Yeah, it's a great question. So the way I like to think about it is we have an equation, the Schrödinger equation. You can read about it in my book, Quanta and Fields, by the way. And the equation makes predictions for what's going to happen. And the simplest reading of the prediction is that the universe branches into these many copies, slightly changed because in one, the electron is spinning clockwise, in the other, it's counterclockwise, but otherwise the universe is the same. And we live in one of those possibilities. We don't see the other ones, and it seems to fit the data. So then you say, okay, what about all those other possibilities? Should we take them seriously as real? And the answer is, if you take our possibility as real, then you have two choices. Number one, either you take the other possibilities as also real, you treat them equal, they're all there in the equation, I'm going to take them seriously. Or you tell me why I shouldn't treat the other ones as real. And there's a long history of people trying to come up with reasons why the other worlds aren't there. Disappearing worlds theories of quantum mechanics, as Ted Bunn has called them. It turns out to be hard. It turns out to be awkward and doesn't fit in well with modern physics. You can try to do it. It's a free country. Go nuts. Like invent all the theories of quantum mechanics you want. Or you can just say, yeah, they're there. I don't care. Like they don't bother me. They don't take up the resources we have.
And just correct me if I'm wrong. When we think of what's called the Copenhagen interpretation, that's the many worlds hypothesis, correct?
No, that's the opposite.
The opposite. So describe the opposite.
Copenhagen is the one that was invented by Bohr and Heisenberg back in the day.
And Bohr is the only one who's Danish in that pair.
Yes, that is correct.
So why does he get the name? Why does his hometown get the name of the idea?
He was slightly older than everybody else, and he founded the Institute for Theoretical Physics in Copenhagen, where all this work was done. So Heisenberg was a postdoc when at this time, and Bohr was a famous physicist. So the Copenhagen puts in the laws of physics the notion of measurement. It says that when you make a measurement of something, a dramatic effect occurs where the wave function that describes the system completely changes. The real hardcore Copenhagen philosophy is that there is no such thing as what the system is doing before you measure it. The whole of reality consists of nothing but measurement outcomes. That's what Copenhagen actually says.
Okay, I remembered learning that, but I didn't connect it with the Copenhagen interpretation. And that's if we would divide into camps, that's my camp. It took me a while to grow accustomed. Let me restate what you just said. It doesn't even make sense to talk about it unless there's a measurement of it. To talk about a state of a system unless you can measure it. And then the measurement is the reality of what things are. Did I oversimplify that?
No, that's actually quite good. And I'm all about, like, the universe doesn't care about you and your measurements. The universe is just out there, and I'm just going to believe in it. Why not? It's the universe is impersonal, and the word measurement should not appear in the fundamental laws of physics.
Dr. Carroll, which science discipline do you rely upon the most when studying a possible multiverse, or is it a combination? Thanks.
And throw philosophy in there as well as a branch of thought.
Why not? Yes.
Yeah.
I presume that the question is referring to, like, is it mostly a philosophical question or is it mostly a physics question?
Or is it mostly quantum physics or relativity physics? How about that? Add that in there.
Sure. There's also, right, different parts of physics are also very relevant here. But this is exactly why I chose to title myself a professor of natural philosophy, because I don't think that there's a boundary or a dividing line between the philosophy of it all and the physics of it all. You are never going to invent quantum mechanics by sitting around in your armchair thinking about how the universe would be, right? You needed experiments that giving you data that you couldn't otherwise account for, and that's what led us to quantum mechanics. But then quantum mechanics leads us to this idea of many worlds happening every time you make a quantum measurement, and philosophy becomes super important for accounting for that, for understanding that. The physicists, bless their hearts, have done a terrible job. Most of them just live in denial and don't even want to think about this. And it's kind of an embarrassment, but the philosophers have at least taken up the challenge. I don't think that we're done yet. I don't think we have a perfect understanding of everything. That's good. That's good for me. Full employment for me and my graduate students. We still have things left to do, but I think you need them all. There's no one answer there.
Dr. Tyson, Dr. Carroll, and the energetic Lord Nice, please help me understand how a photon traveling between stars experiences no time, yet also has a wavelength pattern and changes over space and time. Is the wavelength a function of the photon, or is it a display function of the space-time medium within which it is traveling within?
People love this question. I get this question. It's and they don't like the answer, which is that photons don't experience things. They're just single particles. Electrons don't experience things either. I think that we get in trouble because we are complicated creatures, right, with senses and memories and things like that. And so we have a feeling for what it is like for time to pass. And that wouldn't apply if we were moving at the speed of light, because then no time would pass. But when we talk about the wavelength of a photon or its path through the universe, we're not talking about its inner experience. We're not talking about its first-person point of view. We're talking about what it looks like to us. The photon passes us by. It has a wavelength. It has a path. It's all relative, as Einstein would have said. It's
Correct.
relative from what the observer sees of the photon
It's relative to the observer. Yeah, and it's also about the math, because that's the thing that that the photon is a particle, but the math is why it doesn't experience time. It has no mass, and it's traveling at the speed of light. So there is no time.
That's right. It travels through a path in space-time that takes it no time from its point of view.
Right.
Okay. However, if you look at muons, a muon knows when to decay. It must have an internal clock. For you to just say a particle, and you even mentioned electrons, doesn't care about time. If I'm a decaying particle, I do care about time.
There is time that the extent of a muon's path through the universe does include a passage of time, but the muon as an elementary particle has no hopes or desires. Sorry.
I think Sean helped me understand entropy best in his books and lectures. Charles Liu made an interesting comment recently that time can be measured by entropy.
Ooh.
I was wondering, is entropy creating time in some strange way?
Let me add some extra punctuation in that question. If entropy goes up with the passage of time, allowing us to deduce the arrow of time by seeing systems left to themselves as we watch entropy rise within them. Could it be that entropy goes up no matter what the universe is doing, even if it were recollapsing? Or is the entropy intricately connected to an expanding universe? So that even if we recollapsed, the entropy would continue to go up.
As far as we know, there's no connection between whether entropy goes up and down and whether the universe is expanding or contracting. You could have it any way. There's an empirical fact about our universe that entropy was low when the universe was relatively tiny and has been growing ever since. But if it started collapsing, we expect that entropy would still be going up toward the future. But and that's part of the actual answer to the question, which is that you have to distinguish between time and the arrow of time. Time could exist without an arrow. And the fact that entropy provides time with an arrow doesn't mean that it explains or accounts for time itself. Like here in this room where I am, if I take my coffee mug and I let it go, it falls to the ground. It falls down. It doesn't fall up. There's an arrow of space here in the room. There's a clear distinction between up and down. But it's because the Earth is beneath my feet. It's not because the Earth is creating space. The Earth is just distinguishing between two different directions in space, up and down. That's what entropy does for the universe.
Wait, but if we recollapse and the whole universe then occupies a small volume, isn't that necessarily a lower entropy universe?
Nope.
We learned from statistical mechanics where you have this like blob of gas and you just let it go and then it will expand and its entropy will go up because there's more places the particles can occupy
right.
and it's not contained within a volume. If the universe is shrinking, the whole universe is in a smaller and smaller and smaller volume. How could you tell me that that universe can also have an increase in entropy?
Do you think eggs are going to start unscrambling just because the universe starts shrinking?
All right. Okay.
Right.
Just in case there's anyone who really wants it out there. I mean, Neil's given a very good reason to think that entropy should go down. And the secret to, for a little bit more technicality, we should care about phase space, not space. That is to say, we should think about both the positions of particles and also their velocities. So the positions of particles are indeed going to get squeezed together if the universe collapses. But the velocities are going to spread all out and do crazy things and increase the entropy of the whole configuration. And in fact, it's going to look wildly inhomogeneous with black holes and empty regions, and it's going to look nothing like our early universe looked.
Quantum and fields, that was 2024?
That was 2024, and the one I'm supposed to be finishing up right now is called Complexity and Emergence 2026.
We find you online with The Preposterous Universe?
That's right. And a lot of my work these days, talking out there is in the podcast format with the Mindscape podcast. Yeah.
Mindscape.
Right,
Excellent. And how often do you drop those?
Every single week.
And at least some of your fans came through us to get back to you again.
Absolutely.
We were delighted by that.
Podcast bros. Yeah.
Sean, delight to see you once again.
All right.
Yeah.
All right. Gary in the house.
Hey, Neil.
How you doing, Gary?
I'm good.
So today we're talking about common knowledge.
Yes.
Common knowledge. But why is that interesting?
If we think about it, we humans have evolved to be social creatures, and we rely upon each other for many things. We use language to communicate and coordinate ourselves. But do we consciously strategize in our social behavior, and are we aware of our own signaling when we interact? And to your point, what role does common knowledge play in our everyday lives?
I mean, I depend on that all the time, just as an educator.
Fine, but a lot of people won't realize that it is something they're using as a tool. Some people will, as you do. And does it then play a role in the big ticket items like financial crashes or political revolutions? Now, okay, I can drone on. I've said enough. Let's introduce our guest.
We're going to connect common knowledge to revolutions.
Let's see.
Okay, we've got the world's expert on that topic. Stephen Pinker, welcome to StarTalk.
Thank you.
My gosh, we go way back, like these decades. This, I think, is your first time on StarTalk. A bad oversight on our part because there's no reason for that. You're too active. Your stuff you work on is too interesting for it to have gone this long without you being on. So thank you.
Better late.
So you are cognitive psychologist. I think that's what they call you. Do I remember you being a linguist, though, long ago?
I'm not a professional linguist,
but that was
I'm
your...
a kind of psycholinguist, which is the psychology of language, which is a branch of cognitive psychology.
That's how I first met you and knew your work.
But for me, language is just one of the amazing things the human mind does. So I don't have a PhD in linguistics, but in cognitive psychology.
Got it. And I have got you here as the John Stone Family Professor of Psychology at Harvard University. So are you in the famous building, the psychology building there?
William James Hall,
the
15-story white building, sticking out like a sore thumb in a Cambridge residential neighborhood.
I got you down here for a dozen books, but several of them are some of my favorite books. The Blank Slate, which had its own bit of controversy, but it's fun to see an intelligent arguments presented into that space. The Better Angels of Our Nature. Oh my gosh.
That's very much, yeah.
It has the two words common knowledge in the title.
In the subtitle.
So give me the full title.
So the title of the book is When Everyone Knows That Everyone Knows ... And there's a story behind that. The subtitle is Common Knowledge and the Mysteries of Money, Power, and Everyday Life. And I can explain all of those
Leave
things.
anything out there.
I know you're a psychologist, but you've put in mysteries.
Yes.
There you go. And then money and power.
Now I want to hear the story behind this title because that's a lot.
Okay. So common knowledge in the technical sense refers to the situation where I know something, you know it, I know that you know it, you know that I know it, I know that you know that I know it, ad infinitum. So it's when everyone knows that everyone knows, and the ... is essential. I had to fight with my editor. He says, "Oh, it'll screw up the computer listings on
that's
Amazon."
The infinity.
That's the infinity. Yeah. So to be distinguished from private knowledge, where everyone knows something, but they may not know that everyone else knows it. And that makes a big difference.
I never thought to think about that.
It's been explored by game theorists, the branch of mathematics dealing with the best strategy when other people are dealing with, have their own strategies. It's a big deal in economics for reasons that we'll get to. It's been studied by philosophers, but it is a psychological phenomenon. It's getting in the heads of other people when they're getting into your heads or still other people's heads. And they've never been explored from a psychological point of view. Now, why is this significant? The reason that it's important is that common knowledge is necessary for coordination. That is, for two people being on the same page, doing things that benefit them both, as long as each one can expect the other one to do it and expect.
Don't we call that civilization?
Well, civilization does depend on common knowledge. On institutions like government, like money. That's the reason that's in the subtitle is the only reason that a piece of paper with Abraham Lincoln on it is valuable is because other people treat it as valuable. Now, why do they treat it as valuable? Well, because they know that other people will treat it as valuable. That's what makes it a currency. Likewise for power. There's no way a government can intimidate every last member of its citizenry. And government has power. A president is a president, and a governor is a governor, and the chairman of the board is the chairman of the board, because everyone treats them as if they are. It's a social reality. Our corporations, our religions, our gods, our conventions, even language itself. What makes the word rose refer to a rose? It would smell just as sweet by any other name. Rose means rose because everyone knows it means rose, and everyone knows that everyone knows. So all of our conventions, all of our ways of coordinating, all of our harmony depends on common knowledge. Just to give a concrete example from Thomas Schelling, political scientist and economist who was one of the originators of the concept. Imagine that, say, a husband and wife get lost in Manhattan. This is the era before cell phones. How can they meet up? He can think, well, she likes to go to a bookstore, so I'll meet her there. But then thinks, oh, but she knows that I like to go to a camera store, so maybe she'll go to the camera store. But then she knows that I know that she likes to go to the bookstore, so she'll go to the bookstore after all. Meanwhile, each of them can kind of ricochet with this useless empathy and still not end up at the same place at the same time. Nothing short of common knowledge, not only knowing something, but knowing that the other person knows that you know, gets them together. Now, common knowledge can be generated by language. And that's how I got into it. That is, in this case, a cell phone call. Although it can also just be a convention, something that everyone assumes that just coordinates everyone. Like, what day of the week do you stay home? Sunday. Why Sunday? Well, because everyone else stays home on Sunday. So that's a good reason for me to do it if everyone else is doing it. So a lot of our society depends on common knowledge. Now, this immediately raises a question. People say, well, you define common knowledge as I know that she knows that I know that she knows that I know that she knows, but no one can keep track of them. That's why you have plots like the honeymooners, or there's an episode in Friends that people always tell me about where Rachel says, Joey, they don't know that we know that we know they know that we know. You can't say anything. And he says, I couldn't even if I wanted. Point being that your head starts to spin when you have to keep track of more than 2 or 3 layers of I know that she knows. So how is this possible? Well, the reason it's possible is that we can get common knowledge at a stroke when there is something that we sense to be public or out there or salient, or you can't miss it, or it's in your face. So if I see something at the same time as I see you see it, then that implicitly packs into it as many layers as we would ever need, and we don't have to think them all through. But it also means that we're really, really sensitive to something that is public, that you can't ignore, versus something that may be known privately. And I have chapters in the book on how that shapes our language, why we don't just blurt out what we mean, but often veil our intentions in euphemism and innuendo to prevent things from being common knowledge. Phenomena like being in the closet. Now, notice the metaphors. In the closet means that it's not public, you can't see it. Coming out means not only can you see him, but you can see everyone else seeing him. But that's a good metaphor for common knowledge. And common knowledge in general governs our relationships as well as our institutions. So it's not just money and power. The everyday life in the subtitle comes from the fact that our relationships of deference, of intimacy, of friendship, romantic relationships, transactional relationships. They all exist because both parties know they exist. What does it mean to be friends? It's not like you sign a contract.
It was an implicit contract in a way.
It is implicit, and it's a complex that depends on common knowledge. Namely, what does it mean for us to be friends? It means that I know that you know that we're friends, and I know that you know that I know that we're friends. That's all there is to it. And so sometimes when we don't want to threaten a relationship, we might avoid common knowledge by hinting, slipping in our intentions as beating around the bush, euphemism, you kind of catch my drift, you connect the dots. Whereas if you blurt it out, then that changes the nature of the relationship.
So what about those where I'll see the common knowledge, but there is what I'll call an acceptable duplicity?
Yeah.
A two-way duplicity.
A two-way duplicity.
Yeah.
Like we're both aware of it.
Yeah.
But at the
Nobody
same
wants to blurt it
time,
out.
I don't want to upset the apple cart because what we got here is good.
That's exactly what I talk about. I have a chapter called Weasel Words. Acceptable duplicity there's all kinds of kind of benign hypocrisy. The politician who resigns to spend more time with his family.
Right.
The escort services. Would you like to come up for Netflix and chill? Let's say you were trying to bribe a maitre d' to jump the queue and be seated immediately. You might kind of holding out a $50 bill in peripheral vision say, is there anything you can do to shorten my wait?
Right.
I was wondering if you might have a cancellation. And not if I give you 50, will you seat me right away?
Exactly. Because that would be crass.
Well, and so what does it mean for it to be crass? What it means is you're disrespecting the relationship you have where he is the authority and he sees you where and when he pleases. You're treating him like a transactional relationship, which is a very different kind of human relationship.
Interesting.
Likewise,
transactional.
What's the difference between you want to come up for Netflix and chill and you want to come up for sex? Well, with Netflix and chill, there isn't really plausible deniability. I mean, she's a grown-up. She knows what it means. But she could have some doubt that that she knows that you know what it means. And she could think, well, maybe he thinks I'm naive and I'm just turning down an invitation to a movie. He could think, well, maybe she thinks I'm dense and that I might think she's naive, or I might think that she doesn't realize that I'm not naive. And so they can go back to their platonic relationship. It's a plausible deniability of common knowledge. Because when you think about it, it's really not that plausible.
Right. Everybody knows. But like you said.
But the thing is, everyone may not know that everyone knows.
Exactly.
That everyone knows.
And what that does is it allows you to save face.
Saving face, by the way, another great, going back to the idea that if common knowledge is so important, as I say it is, and it requires, I know that she knows, which makes your head hurt, how could it work so well? And one of the reasons is that we talk about it not using the language of philosophy or game theory, but metaphors of something being visible out in the open. That's why we use expressions like in the closet or saving face. Face is the part of you that other people see and that you use to see other people. So saving face or losing face is a great metaphor for
really
common
saving
knowledge.
the facade of your face, in a way, right? Saving the face that you had established prior.
Face and facade are related.
Do you know in the movie Back to the Future, there's a deleted scene. The Doc is setting up his connection to the clock in anticipation of the lightning strike.
Okay.
And the cop comes by and say, "Oh, Doc, what you doing?" "I'm just doing some weather." So then he comes down and goes up to him. This is the deleted scene. He walks up to him, opens his wallet, and there's just cash there. He bribed him, but that's kind of out of character with how he's just a lovable, doddering old scientist.
That would have damaged his character.
It would have damaged the character.
Yeah, that would have damaged the character.
But that would have been a perfect example.
It's transactional.
Well, the thing is that it's in fact transactional, but it's very dangerous to suggest to a cop that you have a transaction.
Right.
In fact, it's illegal.
So he just makes it visible.
Exactly.
That's all it is.
So it's not plausibly deniable, but it's deniable that the other person knows that you know, or knows that you know that he knows that you know.
Right.
And that's what flips it from deference and respect and authority to transactional. And you want to avoid that flip, but you still want to do business.
Right.
There
That's
was a
why they're weasel
scandal,
words.
because I'm from Philly, and it was, of course, Philadelphia politicians, but I forget the name of the scandal, but it was very famous because they caught it on tape, and only one politician didn't go for it. But these people, these feds dressed up as like Saudi businessmen.
Oh, abscam.
They had like piles of money, like sitting out.
That's been done a number of times around the world.
As they were discussing what they wanted.
Oh.
And then only one of the politicians was just like, "Yeah, I'm not worried about that. Let's talk about."
okay,
and
too.
everybody else went down because
It was the financial seduction.
Yes,
is what that was.
But they never said this money is yours. They just put a pile of money in front of them.
Veiled bribes.
Veiled bribes, okay.
Veiled threats.
Veiled threats.
I quote an episode from The Sopranos in which a member of the family approaches a high school acquaintance and says, "Hey, great to see you, Danny. I hear you're on the jury for the Soprano trial. It's an important civic responsibility that we should all take part in. You've got a wife and kids. We know you'll do the right thing." Oh. That's a veiled bribe.
Right.
Now, of course, extortion is illegal.
Right, right.
I mean, in everyday life, there are occasions where there are implicit veiled threats that you don't spell out in so many words because that establishes a relationship of dominance. And you may want to avoid that relationship while still getting the message.
That would completely change the dynamic.
If you think of the different kinds of relationships, so the basic kinds of relationships are communal sharing, warmth, intimacy. That's one model. Another relationship is hierarchy, alpha male, pecking order, top dog. And the third one is transactional. Now, where cultures differ is not across the board, but in what kind of relationships, parent, child, student, teacher, employee, boss, friend, what resource, money, favors, sex, and in what context, home, school, public. If you mix and match those, that's gives you kind of all the variation from Anthro 101. And so there's certain resources. So for example, there are cultures that really openly trade brides or daughters to become brides. Ours doesn't commoditize that explicitly, but we do say buy and sell land, which some cultures don't do, where the land might be communal. And so if you think of all the resources, all the contexts, all the
it's quite the
pairings,
matrix of
that's the
how
matrix.
that can come
That's
together.
kind of the matrix of Anthro 101.
Wow.
So if we look at common knowledge as a variant of culture, and different cultures prize certain common knowledge differently, how often do we get the misinterpretation of our common knowledge?
We often get misinterpretations when they're cross-cultural encounters.
Exactly, yeah.
And that's part of what culture shock is. You don't know what is the common knowledge in the new community that you have to deal with. And that can result in war. Could result in war. I mean, it can result in misunderstandings, sometimes comical ones, and it's used in comedy, as in Coming to America, as in Borat, where you have the bumpkin from one culture using the assumptions that were native to that guy's culture, but completely inappropriate, sometimes leading to embarrassment, sometimes to shock and outrage.
Yeah. And then if we look at the communication through body language or unintentional signaling.
Yeah. So there's I have a chapter called Laughing, Crying, Blushing, Staring, Glaring about nonverbal common knowledge.
Couldn't get a long
generators.
title then.
You know, right?
Laughing,
Crying, blushing, staring,
Glaring.
glaring. Okay.
Now, we have dozens, maybe hundreds of facial expressions, smiling and frowning and grimacing and so on. But on top of that, we have some really conspicuous forms of nonverbal communication that have puzzled people for millennia, such as laughing.
Yes.
Why do we interrupt our speech with that staccato noise? For these conspicuous displays, blushing is another one. Why should blood go to your cheeks? Crying, why should
Eyes
fluid
shed
drip
tears,
from your eyes? Why do you shed tears? I suggest that they are common knowledge generators. So when you're laughing, you know you're laughing because your breathing is interrupted. Other people know you're laughing because they can hear it. Other people know that you know that other people know, etc. Blushing, you feel the heat of the blood, the inside in your cheeks, knowing that other people can see the change in color from the outside, and they know that you're feeling it, all the more so when they say, "You're blushing."
I've never had that problem.
Darwin worried about this because Darwin was a big proponent of universal emotions. In fact, for him,
He had a whole book on it.
the expression of the emotions in animals and man.
Yes.
And in fact, he used it, in fact, as an argument against the kind of the scientific racism of his day, which said the different races were independently evolved or created, one or the other, either one.
Right.
And he said that the similarity in facial expressions, in many other aspects of emotion, showed that we all descended pretty recently from a common ancestor.
Wow.
And his data, I mean, he was kind of an invalid, but he corresponded with colonial officers and missionaries and traders all over the world, and he gave them questionnaires to ask of their interactions with local people, which they then mailed back to him.
Just to be in context, this is before photography could capture it.
Right.
Although
I'm just at the dawn of photography, what that is.
In fact, his book, this book that we're talking about, was the first use of scientific photography. Although not for cross-cultural studies, because the missionaries didn't have cameras out there in the field. But he actually used it to analyze the musculature in facial expressions, including studies where they got a person in an asylum and they shocked the different muscles to see what they did to a facial expression. That was a bit of a digression. Going back to the question, though, of
Asylums, all they ever use is electricity on you.
But he asked the question, do dark-skinned people blush? And is it detectable? And at least the answer from him, and the answer that I got from Nina Jablonski, who's an expert on skin color, is yes. It may not be.
I'm not denying it. I'm just saying it's not an active referent in our comments of people's emotions.
But I even cite a Ghanaian physician.
Ghanaian?
Yes, very dark-skinned, who said, well, my mother can tell when I'm blushing. The point is that it's a common knowledge generator in that you know that you're experiencing it. You know that other people can see you experiencing it. They know that you know you're experiencing it. Tears, you're looking at the world through a scrim of fluid. It blurs your vision at the same time that other people can see the glistening or the trickle.
Yeah.
So again, you know that you're crying. Other people know that you know that they know. And eye contact is the ultimate common knowledge generator because you're looking at the part of the person that's looking at the part of you, that's looking at the part of them, that's looking at the part of you, ad infinitum.
Here we go
Although
again.
you don't have to think about it ad infinitum.
But what about
It's
the
very
eyebrow
powerful.
thing? The stern look.
Glaring, yes.
Why should that mean anything other than what it means?
Well, Darwin dealt with that in the book, where he noted that some facial expressions are vestiges or remnants of facial postures that animals do when they're about to attack or they're defending themselves. So in the case of the fear expression, he noted that if you're likely to be a prey animal or someone who's going to be picked on by the alpha, you've got to open your eyes wide to see where threats might be coming from. If, on the other hand, you're the predator or you're the alpha,
You want to focus.
Exactly.
Yeah.
And if the remnants of that include, and so the furrowing your brows, which I think narrows the field of vision, that may even narrow if the folds of skin actually intrude on the pupils, might increase depth of field.
Yes, it does.
That is,
yes,
that you
optically.
see optically.
That's why people, if they don't have their glasses on,
They squint.
and they squint.
They squint, exactly.
They don't even know that they're increasing their depth of field by doing so.
Yeah.
I mean, they're not actively thinking it. They just know they see better.
Going back to these nonverbal common knowledge generators, we use them to make something public that formerly was private. That's
Within
the
us.
common denominator. Yes.
Yeah.
So in the case of eye contact, now that developed way before we were humans, because among primates, eye contact is a threat signal. The dominant stares at the subordinate who looks away, which is, by the way, also true in humans. The boss
Don't
looks
make
at the
eye
employee.
contact. I had a
Who are you
young
looking at?
person
Exactly.
walk past me yesterday evening, and I'm thinking, if you don't look up, you are going to walk into me. And it was intentional not to make any eye contact.
Well, the anthropologist Irv DeVore used to tell his class, if two human beings look into each other's eyes anywhere on Earth for more than 6 seconds, then either they're going to have sex or one of them's going to kill the other.
Why is it so uncomfortable? I mean, even like I don't mind making eye contact, especially if the person's decent looking. But prolonged eye contact, and I don't know if it's just me, but I'm just going to put it out there. I'm going to be honest. It gets a little like creepy and uncomfortable.
Oh, it absolutely does. Okay, so, and I actually write about this. So what we call eye contact in ordinary conversation is it's a bit of a misnomer. Your eyes kind of dance all over the face.
all the time.
You spend a lot of time lip reading, but it's the eyeball to eyeball stare that's really which is something different. Now, we're humans. We're not, we're not monkeys. We're not gorillas. And so eye contact doesn't have one meaning. I mean, it can be seduction, it can be threat, but more generally, it can be something that formerly was private knowledge is, as of this moment, common knowledge, which is why we say things like, can you look me in the eye and say that?
We're trying to interpret so many different things,
Or when
and that's why you get uncomfortable.
And when you're embarrassed, you look down, you look away, you avoid making eye contact. So what laughter does is it makes what used to be private knowledge, common knowledge, where it's some indignity or infirmity or weakness of some butt of the joke. Now, that can be someone that you're trying to bring down. It could be someone you're trying to keep down in aggressive humor.
Yeah.
Although there's also, of course, convivial humor, what we've all been doing, where the signaling is to reinforce the Egalitarianism is the basis of warmth and friendship. There's always a danger of a dominance creeping in. With any two people, one of them is going to be, more,
of course,
better looking, smarter, richer, more powerful. But that's not what you want to do when you're friends. When you're friends, it's like we are all on the same level. And so by calling attention to some weakness in yourself, that you could lord over people, but you don't want to lord over people, or vice versa, gentle teasing and joshing that the other person accepts, then you're reestablishing the common knowledge that the basis of our relationship is
self-depreciation.
Yes, exactly.
What does one do for, is it whatever the number is it 1 out of 10 or 1 out of 6 of us who's on the spectrum, where social cues do not play?
Exactly.
Might that be adaptive, where now you don't know anything about me because my facial expressions are not responding, and therefore I'm not revealing my inner secrets to you?
Well, there is
that could have survival value.
I suspect that's more likely used strategically, as in the poker face. That is the poker face where you deliberately hide the tells. In a case where you're not in a situation of cooperation, but zero-sum competition, then any kind of tell could be used to your disadvantage.
All right, to go back briefly to the animal theme.
Yeah.
What about the elephant in the room? You know, the Emperor's New Clothes scenario.
So I actually open the book with the Emperor's New Clothes because that's a story about common knowledge.
Yes.
When the little boy said the emperor was naked, he wasn't telling anyone anything they didn't already know. But he was changing their knowledge, because when he blurted it out in public, now everyone knew that everyone else knew that everyone else knew. So he converted private knowledge to common knowledge. So first of all, that made a difference. That was the climax of the story. And what it is, it changed their relationship with the emperor from deference to ridicule and scorn. So a relationship
to the emperor or to the
emperor,
to the tailor.
Well, but to the emperor too. At least in the
tailor. But the tailor fooled him. Did I have a Disneyfied version of that story? I mean, the tailor is the one who should be.
Yes, but at that moment in public, it was the emperor.
The emperor
who
suffers all of the embarrassment,
especially in the Danny Kaye version of the story, where it was met with ridicule and scorn in the lyrics to the song.
Okay,
and deference is a matter of common knowledge. You defer to someone because you know they'll stand their ground. Why do they stand their ground? Because they know that you'll defer to them. And how do they know that? Well, because you know that they know that they'll stand their ground ad infinitum. So,
and what about the mutuality of respect? I mean, that's the flip side of that. Sometimes there's a matter of deference because you truly respect the person. They understand that you truly respect them, and they respect that,
Yeah, there are different flavors of the hierarchical relationship. It could be dominance, which basically means, I could hurt you if I wanted to. There can be status. I could help you if I wanted to.
Oh.
There can be expertise. You all have a common interest in the decisions being made by someone who knows what they're talking about. Or even sometimes if everyone's going in, the expression herding cats, even if no one has a particular reason to be the decider, it's best for everyone if there is a decider, and that can give you a hierarchical relationship. But we do use metaphors like saving face out there, and the elephant in the room is obviously something that everyone can see and that you can't ignore.
It makes sense.
So the elephant in the room is the Emperor's New Clothes, because no one is talking about it.
That's right.
Even though everyone knows that it's there.
Listening to you so far, I get the feeling that there's a kind of a logic to common knowledge, and maybe even like a code. And that might then culturally vary.
Yes. So I think the phenomenon of common knowledge and things that generate it, like blunt speech, like eye contact, is universal. But then what are the relationships that are negotiated with common knowledge or ratified by common knowledge? That is, what can friends share? What can a boss demand of an employee? How is sex treated? Can it be transactional, or is it only intimate? All of these mixing and matching of resources, relationship models, and contexts, that's what makes cultures differ from one another. But in each case, there is some kind of common knowledge that holds the relationship in place, that sets out what you're allowed to exchange, what you're allowed to hoard, what you're allowed to demand. And that's what it means to be a competent member of a culture, to master that. Each one of them being a matter of common knowledge.
So, Stephen, I try to know what is common knowledge so that I can access it as an educator. I can tap it into it. I can add to it because I don't have to train people to know things that represent common knowledge. Comedians, your joke does not work unless everybody knows what you're talking about.
The more universal, the better. It's about experiential knowledge. Even if you've never been through what I am talking about, if I can put you there, then you will laugh with me. There are many comedians that talk about marriage, and people who are single laugh because they have observed somebody else in a relationship that they understand what this comedian is talking
so
about.
that broadens your access points to the person.
What humor often does is it establishes common knowledge. That is, if you get the joke, then what has just been made public is something that you privately knew along. And so you get that feeling of solidarity with the other person. If you're laughing at the same thing, then what was unstated that makes the joke funny is something that you have in common. That's why humor is such an important bonding agent in dating. One of the main criteria that in accepting a mate is
sense of humor.
Sense of humor. And sense of
I
humor has
never
to be
thought deeply about that fact.
And it has
I just
to
thought
be-
it'd just be more entertaining, but it's more bonding.
What it means is that you share a lot of common ground, common knowledge. That is, you can't get the joke unless there is some hidden, unstated premise that makes it work. And that can bond people. It can also be a devastating put down and an intolerable insult. I give the famous example of the roast at the National Press Correspondents' Dinner during the Obama presidency, where Donald Trump was in the audience and Obama made a number of jokes at Trump's expense. Ordinarily, people are expected to be a good sport and to accept the barbs, showing that they have commonality, common ground with everyone in the room. But Trump took it personally. He was visibly fuming and scowling at a joke like, well, it would be good if Donald Trump was president because he could accomplish things like closing Guantanamo because he has a history of running waterfront real estate into the ground. The point is that everyone who laughed, first of all, knew that Trump, despite his boasts of being a business genius, had a string of failures, which made it all the more painful for Trump for that to be brought out into the open. According to some stories, that's what led him
To run in the first place.
for revenge.
What happens when the humorist just twists the common knowledge? And I think you touch this in the book, toilet paper shortage.
Oh, yes.
And the origin of that story.
So there's some viral fads and phenomena which can be really significant.
So common knowledge is a kind of virulent property.
It can be, yes,
Yeah.
exactly. So in the case of, say, a bank run, where a rumor starts that the bank might be in trouble. Now, of course, banks don't have enough cash on hand to redeem all their deposits.
Right.
But if you worry that other people worry that still other people worry that other people worry that the bank might be insolvent, then everyone rushes to the bank to withdraw their savings, which can actually cause the bank to fail, even if it was sound. And that can bring down an entire economy. That was in part the cause of the Great Depression.
Right.
And so when Roosevelt said the only thing we have to fear is fear itself, this was a theorem of common knowledge. It wasn't just a feel-good bromide, but he was accurately diagnosing the situation. Once again, something that is public can then set off cycles of thinking about what other people are thinking about what other people
That's
are
the
thinking.
virulence.
And a similar phenomenon might be why there was a toilet paper shortage. It actually wasn't a toilet paper shortage until people thought there was this toilet paper shortage. So they hoarded because they thought other people were hoarding. When stores started posting maximum 3 rolls per customer, that didn't so much throttle the demand as it reassured everyone
That there
other
was a
people,
shortage.
Well, that other people wouldn't be able to strip the shelves bare, so they didn't have to worry about stripping the shelves bare. I only need 3 rolls, but I'm only going to ask for 3 rolls because none of the other people can buy more than 3 rolls either.
Right.
And so that kind of
It's a level setter.
According to one story, it came from a big common knowledge generator in the day, namely Johnny Carson on The Tonight Show. So in the old era of 3 networks, Johnny Carson was the king of late night. He hosted The Tonight Show for many decades. When you were watching it, you had a good reason to think that the rest of the country was watching it and knew that the rest of the country was watching it. In the early 70s, after the oil embargo, when there was an oil shortage, he made the joke one night, we have shortages of everything these days. There's a shortage of gasoline, there's a shortage of meat, there's a shortage of coffee. But did you hear the latest? I read it in the papers. There's a shortage of toilet paper. Now, it turns out there wasn't a shortage of toilet paper.
That was just a joke.
But as soon as he made the joke,
Bang.
there was a shortage of toilet paper as everyone started to hoard toilet paper.
Self-fulfilling.
And according to at least one theory, ever since then, whenever there is a hurricane or a blizzard, people think that toilet paper is the thing you got to stock up on because everyone else is going to.
There was an
start
episode
hoarding
of
it.
Curb Your Enthusiasm where someone was revealed to have an entire closet full of toilet paper.
Oh yes, during the pandemic. Yes, that's right.
An entire closet.
Well, in the other direction, you can also get speculative bubbles. You buy crypto because you think other people are buying crypto, or at least will want to buy crypto tomorrow, so they'll pay for more for it tomorrow than you paid today.
Right.
And they're buying it tomorrow because I think they'll sell it to someone who wants to buy it the day after tomorrow.
The hot
And that can
potato.
inflate- The hot potato. Yes, or the greater fool.
The greater fool.
And that goes back to John Maynard Keynes, who in the 1920s compared speculative investing. So this is investing not because of the return that you expect on the asset, that is the profits that the company, the manufacturer will make selling widgets, or the farmer selling food, but you think you can unload the security at a profit on someone else.
Right.
And he said it's like a beauty contest where instead of picking the prettiest face, the object is to pick the face that the most other people pick, where they're picking the face with the same goal, that is trying to figure out what everyone else is picking. So it's sometimes called a Keynesian beauty contest.
Don't we have that in primaries with elections?
And in
Similar thing?
elections
Yeah.
are Keynesian beauty contests. That is, in a primary election where there might be a field of a dozen candidates, and no one wants to waste their vote in just deciding who's going to come in at seventh place as opposed to
Which
eighth
is what
place.
ranked choice voting is trying to resolve.
That's
resolve.
why, yes, that's exactly what it's trying to resolve. And so people are hyper aware for any signs that someone has momentum, that they're in the lead, because they want to vote to determine who comes in first, not who comes in sixth.
Right. I don't want to waste a vote. That's
I
what
don't
they
waste
say.
a vote. And so during the coverage, any various trivial gaffes and lapses or boosts can sometimes shoot a candidate to the top or sink their candidacy. The Trump phenomenon is interesting because what he is done repeatedly is that he has floated norms that everyone thought were inviolable. They were inviolable only because people thought they were inviolable.
Exactly.
And they were existed as common expectation, common knowledge. And as soon as he flouted them and did not pay the price, they no longer existed as norms, which is why they're, I think, being copied by people like Elon Musk, also a troll, a liar, a braggart, that things that would be unthinkable for a president, for a CEO, as soon as they're thinkable, they're thinkable.
So is this the fracturing of common knowledge that is partly behind the polarity of society right now, where people are just refusing and disinterested mainly to find a common ground?
Yeah, so common knowledge is always is defined relative to a network of sharing of information. It could be two people in some of the examples we've discussed. It could be the entire country. And there has been a segregation into two separate pools of common knowledge. Everyone blames social media, and that probably has something to do with it.
Yeah.
But I think it's also cable news, Fox News, prior to social media had that effect. You weren't watching Walter Cronkite at the same time as everyone else was watching Walter Cronkite or Johnny Carson. And residential segregation. When you had educated people flocking to cities, leaving behind the less educated, when you had a decline in organizations that brought people together across the socioeconomic divides, like the Army in the era of the draft, like churches, like service organizations, like the Lions Club, like bowling clubs. You stopped rubbing shoulders with people from different social classes. Each one then hung out with people like them, and then the common knowledge that they shared started to grow disjoint.
Yeah, so it feeds divisiveness because, I mean, it's the same issue, as you said, multiculturally, right? Except now it's within the same culture, but now people are dividing with the same motive. Not the same motive, with
Different cultures within the same country.
within the same country.
Yeah.
That makes me feel like it's exacerbated by what I'll call the vituperative disposition of leadership right now.
Yeah.
So
I don't know what that word means.
It means like mean and nasty,
Gotcha.
like
Okay.
a viper.
Okay.
So when we're siloed into these different camps like this, it becomes very easy then to point fingers and say, that's your enemy, that's your enemy, that's your enemy. And then it's okay to be mean and nasty towards those people. And it seems like that's exactly where we are.
Norms of civility, things you just don't say. You might disagree with someone, you might even not think highly of them, but you don't insult them to their face. I mean, you do in the playground, But there was a norm in politics, in corporations, in the media, that you pretend that you like them even if you don't. And those are some of the norms that are shattered. You don't lie blatantly. Now, everyone lies somewhat. Just all of us probably tell 2 lies a day. But you don't blatantly lie. You don't show a contempt for the truth. You at least try to pretend that you're honest.
Can I give an example? I befriended I have a sort of Republican confidant who was in Congress for like 25 years. He was in through Reagan and beyond. And then I was talking to Al Gore, and I was saying I was friends with this guy, but I had to work it because we come from different places. And you know what he said? He didn't say anything bad. He just said, yeah, he's an acquired taste. That was pretty politic.
That is a very politic.
Right? He didn't insult. He just said, you gotta work it, and then as any acquired taste would be. So that's an example. You don't hear that today.
What plays out if society remains unchecked, where the common knowledge is distorted or the common knowledge is dictated by the loudest voice, no matter what that voice is saying?
Yeah, by nefarious forces.
Yeah.
Influencing.
Yeah, well, we're seeing some of it. We're seeing the polarization, particularly the negative polarization, that is not just disagreeing, but thinking that the other side is stupid or evil. I don't have an algorithm for reversing that, but the kind of norms that we should spread would be ones of civil disagreement, epistemic humility, charity, things that go against human nature, where we tend to think of argument as a competition, as a war. I attacked his arguments, he defended them, but then I demolished them. We use the metaphors of war in talking about argument. Yeah. And in one of the chapters, I talk about a different model for argument, coming out of a mathematical theorem, claiming that rational agents should not agree to disagree.
That's how I feel, by the way.
Well, there's actually it's a proof by the Israeli mathematician Robert Aumann that depends on common knowledge. We don't have time to go through it now, but it does set a kind of an alternative paradigm for argument, that instead of 2 people beating each other up and the one left standing wins, that's not how you discover the truth. Or even bargaining and negotiating and you come to some compromise. You think about, why should the truth just happen to lie halfway in between 2 opinionated guys? But rather it's kind of a random walk where when 2 people exchange information, they might go all over the map until they converge on a common conclusion.
That's precisely how I feel.
The progress of science shows it's the best way to do things. And even, of course, scientists are not immune to pissing contests, dominance contests. And that's, at least we acknowledge it's a bad thing. For that norm to spread in journalism, in politics, in the court system would be a good thing.
It would be transformative.
More truth, less vituperation.
Yeah, I think we got to call it quits there. Oh my God.
It was a great conversation, man.
Let me see if I can take us out with a quick cosmic perspective, with your permission.
If you're feeling it, do it, man.
Yeah. I spent my life studying the universe, which is a huge, complex place. All the laws of physics I learned in physics class are applied in some place, in some way, at some time in the unfolding universe. Also the laws of chemistry and our search for life in the universe. There's the biology that we bring with us. All of this. And every time I reflect on that, I think to myself, this is not the hardest thing we can think about out there. You know what the hardest thing is? The human mind. What's going on inside there? And we've got psychologists, with neuroscientists. It's a whole field trying to figure ourselves out. And, I'm glad I do something as easy as astrophysics relative to what they've got to worry about. And I just hope that the study of the human mind by the human mind is not the most complex thing we ever have to tackle in this universe. But if it is, get ready for that ride, because the human mind is not logical, it's not rational, only occasionally. It was not only the source of everything we value and call civilization, it may actually be the end of it as well, if we're not careful. And that's a cosmic perspective. Stephen, thanks for joining us.
Thank you so much.
All right.
It's been a great pleasure.
It was great.
Thank you.
Stephen Pinker's latest book. Give me the title again.
when everyone knows that everyone knows ...
Today, I'm in conversation with the one, the only, Richard Dawkins. Richard, welcome back to my office.
Thank you very much.
This is like your fourth time here or something. I've lost count.
Something like
something
that.
Like
always,
that.
Always a pleasure, Neil.
We have a lot of catching up to do, I think. So recently, or at least this year, we lost Daniel Dennett, philosopher Daniel Dennett. I recently learned, I didn't read all of his books, I read some of them. He declared that Darwin's evolution by natural selection was the greatest idea anybody ever had. He's coming to it not as a biologist, but as a philosopher. So how do you reflect on that declaration?
He said that at the beginning of his book, Darwin's Dangerous Idea. And his point was that before Darwin came along, it seemed obvious to everyone that big, complicated things like humans and oak trees and things had to have an explanation in terms of design. And it was a huge stroke of insight for Darwin to see that it didn't, that the laws of physics alone could produce this prodigious amount of complexity filtered through this odd process of natural selection. To me, it's always been strange that it took so long, that it took until the middle of the 19th century for Darwin and Wallace, and even maybe one or two other people.
This is thousands of years of thought.
Yes,
and brilliant people have come before.
Aristotle could have had it and didn't. I mean, when you think how much cleverer you had to be to do what Newton did, or Leibniz, inventing calculus, you'd think that somebody would have tumbled to evolution by natural selection before the middle of the 19th century, yet they didn't. And so that's an astonishing thing, and it needs an explanation.
Did Daniel Dennett explain why it took that long? And if he didn't, what would be your explanation?
I don't remember whether he did. Well, first of all, Ernst Mayr, the great, he was here, I think.
Here at the American Museum of Natural History.
He thought it was because of essentialism. He thought that because of Aristotle and Plato, who thought that just because they thought like geometers, I mean, a right-angled triangle is a kind of perfect form sort of hanging out there. And they thought that the perfect rabbit, the perfect rhinoceros was hanging out there just like a right-angled triangle. So you couldn't imagine how a rabbit could turn into anything different. That was his explanation. That wouldn't be mine. I mean, I think it's just that.
That's an interesting one, though, because it speaks to the bias that we have observing nature. I mean, even in my field. So my people, including Copernicus, could not shake the idea of orbits that were perfect circles. They couldn't shake that. Why would God design a universe with a shape that wasn't geometrically perfect? So even Copernicus, putting the sun back in the middle of the known universe, had circular orbits. And since the orbits are not circles, they actually differed from predictions on the night sky. So that was a problem at the time. It's like Copernicus, this might work, but it still doesn't fit. The epicycles are doing much better. So it wasn't instantly taken up, including the resistance, the church resistance, of course.
Of course, yes.
Earth wasn't in the middle anymore. Our counterpart to what I think you're describing is the urge to try to presume nature was perfect and then account for it with everything we know that is.
Going back to why it took so long and the idea of the perfect rabbit, the perfect rhinoceros, the perfect horse, in a way that's a bit silly because if you want to look at, I mean, a population of rabbits is pretty variable. And anyway, that was Ernst Mayr's explanation for why it took so long. Darwin did it by going via artificial selection. Everybody knew, farmers knew, horticulturalists knew, gardeners knew that you could change a rose, you could change a cabbage by just breeding. And really Darwin's insight was say you don't actually need a breeder. You don't need a human to do the breeding. Nature does it for you. Survival does it for you. It's not that difficult. I mean, it doesn't require any sort of higher mathematics or anything. And yet nobody got it until Darwin and Wallace.
And this is why I'm intrigued that Daniel Dennett, a philosopher who, in principle, any philosopher could have come up with this, because unlike relativity and unlike quantum physics, which are realms of behavior of the universe, large and small, that you can't just deduce from your armchair. But evolution by natural selection could have been deduced in an armchair. It just wasn't.
It could. It's surprising that it didn't. It's interesting that both Darwin and Wallace were traveling naturalists, and they both were collectors in South America. Both were in South America. Wallace lost his entire South American collection in a fire. And then he went to the Far East. But they were both collectors of natural history specimens. And the other person who might have thought of it is Patrick Matthew, who was a gardener and an orchard keeper. But philosophers know they didn't do it.
They didn't, and they could have.
They could have, yes.
So you've written, I mean, I have a list here of like all your books. You've been out of control. So I thought I'd have a short exercise here. I'm going to mention your books. Could you just tell me what your favorite bit of that book was that you were communicating with the reader, if I may? So start off, The Selfish Gene.
Natural selection chooses between genes. Genes are the only thing, the information contained in genes. Digital information is the only thing that goes from generation to generation. That which survives is information, digital information. Some genes survive better than others. We, the bodies, we, the animals, we, the plants, are just the machines that are there to preserve the genes that ride inside us.
That reminds me of how I describe your gut bacteria. I say, people want to think they're like top of the world, and I say, all you are to those bacteria is a darkened vessel of anaerobic fecal matter.
And it's pretty much the same with your genes. I mean, it's not fecal matter; it's testicular matter or ovarian matter. But yes.
Okay, so they're the ones carrying themselves forward.
Yes.
So if it's just information, can you imagine a day where the biology is no longer necessary, and you just have the digital information stored or duplicated in some way?
Yes, certainly. You could. I mean, already you could preserve your entire genome. I mean, I've got my entire genome on one disk. The idea was, it was a television program, and the conceit of the program was it was going to be posted into the family vault, the Dawkins family vault in the church at Chipping Norton.
Oh my gosh!
To be dug up in 1,000 years. And they were
like a time capsule.
Yeah, yes. Exactly. And the idea was that in 1,000 years they dig it up and make a duplicate of me. And of course, then we talk about why it wouldn't actually be me, because it would just be an identical twin of me. But that was the idea.
It was, no, if you had a book of a picture of your mother.
I think you're thinking of
your mother's mother.
Yeah, you pile them up. It's just one of many ways of dramatizing the enormity of geological time. I forget exactly how it goes. There are lots of ways of doing it. I mean,
no, but you do this, and if you keep doing it, one of those pictures is
a fish, and yet every single generation looks like the previous one and the next one. There's no sudden discontinuity.
It's not sudden.
And many people can't grasp this. They think, well, there must have been a time when it stopped being a fish, and but there wasn't. It just gradually changed.
Okay, will you allow me, given this, which I completely understand, you have to allow me my explanation for the chicken and the egg.
Okay.
Okay. So I tell people, but I've never gotten your blessings on this. So I simply tell people, they say, what came first, chicken or the egg? I said, the egg. It was just laid by a bird that was not a chicken.
Yes.
That's a fair statement.
It was laid by a dinosaur.
I'm compressing a billion, 100 million years of time there.
Yes.
But at some point, you're going to say what comes out of the egg is a chicken. But that's a genetic alteration from the previous generation.
But there never was a moment when a bird that was not a chicken gave rise to a chicken. It never was.
Of course. So this is a very compressed,
yes.
It's a shorthand for what you just said with the book of your ancestors, going back to the fish.
Yes. I once had a letter from a lawyer who said, roughly speaking, evolution can't be true because a species is defined as members can always interbreed with each other. And you can't imagine that there was a time when child generation was incapable of breeding with the previous generation. Of course, you couldn't. But he thought that meant that somehow evolution was invalid. He couldn't grasp
that everything was specially created.
Yeah. Everything is, it's a gradual process all the way through. And as you step back through your ancestors, they become slightly less like a human, but you never notice it as you walk past them. If you imagine...
I want to see a fish. So you skip ahead and there's a fish. You say, that's my parent.
Yes.
That's
Yes.
it's a little freaky for people.
But
you gotta appreciate.
as you walk along the generations, you'd never see them getting more fish-like. It would just be so gradual, you would never notice it.
Because generations are only 30, 40 years, and we're
Yes.
talking billions.
Yes, that's right.
You needed deep time for evolution to do what it needed to do. Even in the 19th century, my people, the most we were going to give you as a biologist or even the geologist was 10 million years, 20 million at tops. We didn't know about energy contained inside the nucleus of the atom yet. Nuclear energy, which is how the sun makes fuel. We didn't know that at the time. So the best we could do was say it was a lump of coal.
Darwin's son Charles Darwin's son George, was one of the people who pointed out eventually that nuclear energy could do the trick.
Which of the Darwins explained tides for the first time?
Probably George. I'm not sure.
It was a Darwin.
Yes.
And Newton and Galileo did not understand tides. It was, even though they had all the gravity necessary
Is that right?
to account for
Yes.
it. There's a subtle point with tides where if you look at any textbook, it'll have like the moon and Earth, and it'll have a tidal bulge pointing towards the moon.
Yes, that's wrong.
It's wrong.
Yes.
It doesn't, the moon would want that to happen,
Yes.
but that's not how it is.
Yes,
The tidal bulge is in advance of the moon in its orbit.
yes.
Okay. And that's Earth's rotation pushing the tides ahead of the moon. And it's that interaction that has remarkable consequences. The moon is slowing down Earth's rotation. And Earth already slowed down the moon's rotation, so it's tidally locked to us.
We'll one day be tidally locked.
We'll be double tidally locked. And when that happens, then the tides will line up because we'll not be pushing it ahead of the moon. So somebody had to figure all that out.
Yes.
So that was another Darwin. Thank you for your Darwins. You came up with the word meme. I know it was you.
That was in the selfish gene.
That was in the selfish gene.
Yes. Yeah.
You invented the word. And people long forgot. Tell me the authentic definition of meme, because that's not how anybody's using it today.
A unit of cultural inheritance, and the analog of the gene in cultural inheritance.
Okay, so this is communicated from one person to another.
Yes.
And certain memes have higher communicability.
I mean, I really wanted to say that because the whole book had been about the gene as the unit of selection, that's how I described it when you asked me earlier, it didn't have to be genes. It could be anything that is self-replicating. And nowadays, I would have used a computer virus as my analogy, probably, for the gene.
Mm-hmm.
But in those days, computer viruses, well, maybe they'd been invented. I didn't know about them anyway. So I used the unit of cultural inheritance. It's something like a tune.
M is for memory, so memory gene. It's a
Yes,
portmanteau.
that's right. It comes from the same root as memory.
Okay. So if I say something, we have alligators in the New York City subway.
Yes. If that spreads, if that spreads because it's a repeatable lie, or even might be true. If it spreads, then it's a successful meme.
Because it's so interesting to me, I
Yes.
have to tell someone else.
Exactly. We love to tell stories.
So nowadays, it's just an image of something kind of cool, you know.
Yes, I'm rather sorry about that.
Yeah. No, I'm not. That's not your fault.
No.
But it's you've contributed to our culture. The best of the memes are the ones that are spread around the most.
Yes.
There's a meme of me doing this. Okay.
Yes.
Like I think, what is it called? Watch out, you got a badass over here. I never said that.
Okay.
And there is a picture of me doing this.
When it spreads.
It spread. And there are people in South America who saw me in the street. They were tourists. And I said, "Oh, we know you from the meme." This is like 10 years ago or something. It's like, the meme, really? That's not even me. Why did they? So somehow that spread. I don't have any understanding of it. So that's a selfish gene. So let's move ahead here. The Blind Watchmaker. Oh, that's my favorite book of yours, if I may.
Okay. Well, The Watchmaker comes from William Paley, the theologian, who said that there must be a God because if you find a watch, you pick up the watch. He was crossing a heath, he said. You open it up. It was a great big pocket watch in those days. And you see all the cogwheels and springs and things. It had to have a designer. Of course it did. And so how much more would you say that of an eye or a knee joint or anything living? So that's the Paley watchmaker argument. Natural selection is the blind watchmaker. It produces results that are like watches. They're beautifully designed. Eyes are beautifully designed. Certain flaws, but they are beautifully designed. And they come about not through any design process, not through any deliberate design, but through the blind watchmaker, which is natural selection. So
So that's hard for people to accept, especially if they're deeply religious.
yes.
Because they already have an account.
Yes.
Now
that's
you're
right.
saying one of the acts of their God is some random force operating.
He didn't have to be there at all.
He didn't have to be there at all.
Yes.
And I think where people get confused, and even some of our people have made this mistake, Fred Hoyle, who was the architect of the steady state universe, who pejoratively invented the name Big Bang to
Yes.
describe the universe beginning in one point. He said that in a pejorative way. He wanted the universe to be a steady state. He did a calculation for how you would get an eye, a fully functioning eye, and how long that would take. And it was some impossibly, 10 to some very high power number of years, given the rate at which you have defects in a genome. And correct me if I'm wrong, the rebuttal to that is natural selection is not completely random.
Well, no, that's right. It actually wasn't an eye. It was a hemoglobin molecule, but it's the same argument anyway. So what he overlooked was that it doesn't happen all in one go. He imagined all the bits coming together at random.
And that's one case that doesn't work, and it has another random thing that doesn't work.
Yes.
And you do that forever.
You use that forever. Of course you want to, but what you need is, let's use the eye, even though he didn't. You need a slightly less good eye, and then a slightly less good eye, and a slightly less good eye. And if you start with just a sheet of light-sensitive cells, which just detect whether it's light or dark, that's useful. It's not like
It's better than not having it.
It's better than not having it. You can tell when it's night or day. You can tell whether there's a predator flying overhead. And then if you have a slightly cup-shaped, if you bend that retina from a flat thing into a slight cup, then if it's coming from that direction, it hits that side of and so you get, it's not an image, but it gives a slight directionality. And then you close up and you start to get a pinhole camera. It's a very crude, it's out of focus, but it's sort of an image. And then you need a little bit of transparent gunk in there. It's not a proper lens, but it does something like a lens. And all these stages, one by one, they step by step, they incrementally improve.
And every improvement is the new starting place for the variations at that generation.
That's right, and then you get improvement.
Because every generation is not starting from zero.
That's right, yes.
Climbing Mount Improbable.
Well, that's what we've just been talking about.
Yes.
Mount Improbable is...
Just that metaphor, describe it to me.
It's a metaphor where you've got a mountain, you've got a sheer cliff, a vertical cliff, and on the top of the cliff is an eye. And to produce the eye in the Fred Hoyle manner would be to leap from the bottom of the cliff to the top in one go.
In one go.
You cannot do it. But if you go around the other side of the mountain, and you find a nice gentle slope, and you can reach the summit.
Okay. So if you think it got there in one fell swoop, there's no, of course you're going to invent a God, because whatever.
That's right.
But not imagining that there's another way.
Yes.
You're stuck in one religious philosophy versus any other philosophy.
Yes.
Okay. All right. Got that. And this one, much was written about unweaving the rainbow. So tell me about that.
Okay.
That was, we're up to 1998 now.
That comes from Keats.
I did not know that.
Keats complained about Newton spoiling all the poetry of the rainbow by explaining it. And so my point was the point which you've made often enough, that actually there's far more poetry in really understanding the spectrum.
So I did not know that Keats had that to say about Newton, because Newton, he decoded the rainbow.
Yes.
That was his thing. That's what he did.
One of his things.
Oh, by the way, you mentioned how beautiful the eye is, even with some flaws. As an astrophysicist, when I would learn this very early, when I took classes here, actually, when I was in middle school at the Hayden Planetarium, that's when I learned about the entire electromagnetic spectrum, and that the visible part of the spectrum is tiny.
Yes.
It's not even a full octave.
That's right.
Of what's out there. And then I was just disappointed with my sight. And later on in Star Trek The Next Generation, there'd be a character called Geordi. He had a visor, VISOR, which was an acronym, Visual Instrument Sight Organ Replacement. So Yeah, I'd be intrigued by what the world would look like that way. For example, if someone's calling you on your cell phone, that would be like radiant microwaves while that's happening. That'd be just kind of cool. Or if you go by the countryside and you see radio towers, they would be the brightest things on the horizon. And now they're just hunks of metal. And so they get him to look at scenes that they're coming upon. It's high in X-rays, it's high in this, it's high in that.
Yes.
And then I worried that if you could see all bands of light, that would be very visually noisy, wouldn't it?
Yes. I mean, if you see right through to radio waves, where you wouldn't, I mean...
Well, then everything becomes transparent.
Long wavelengths. That's right.
You have coined this term, and we've even appeared on stage together under this title, The Poetry of Reality. And I'm all in. But if you're actually a poet, surely there are parts of reality that are best expressed by a poet. Would you agree?
I suppose so. I've never quite understood. I mean, I don't write verse, but I suppose, like you, I try to evoke emotion at the same time as
Otherwise,
science.
it's just a wiki page.
Yes,
right.
that's
You
right.
want some...
And I'm not entirely clear what you mean by poetic. I sort of feel intuitively I know what it means, but I can't quite put it into words. Maybe that's no accident. Yes, I defend in my own mind the idea that science is the poetry of reality. It makes me feel poetic. And I think it makes you feel poetic.
So it might be self-serving on that level. What would matter if others can be convinced of the same? Because otherwise it's just a self-licking ice cream cone.
That's right. And if you're skilled in writing, I think you can bring out others with you.
For me, poetry, art more broadly, best serves us when it highlights something you might have otherwise missed or never noticed.
It's a good way to put it.
My best example of that was July 21st, 22nd, was it? After we landed on the moon in 1969, the New York Times had a special section, people reacting to the fact that we walked on the moon. And there were all these famous poets of the day. There was Archibald MacLeish and, people who carried the soul of creative expression in the day. And I read these poems and I'm thinking, none of this is greater than the act of walking on the moon itself. So maybe I don't need artists to interpret that for me. Maybe I need them to interpret the tree that I'm walking by. And then you get Joyce Kilmer's poem, The Tree. I will never see something as lovely as a tree. The arms pressed to the sky. There's in American poetry, Henry Wadsworth Longfellow, who wrote The Midnight Ride of Paul Revere. That might not be heralded as great poetry, but we all know it here in America. And that's a poem about a guy who told other people that the enemy was coming. Is that an important person? No. Yet we all know that person's name because it's a poem about him. You do not know that corresponding person for any other war that has ever been fought in the history of the world. The person who told other people that the enemy was coming. That is not a person. But for us it is because it was a poem about him. It was somebody who would otherwise go forgotten. So for me, art is best when it captures that. Give me a point of view that science does not give me. Then we can hang out together in the sandbox. That's how I feel about it.
The tree poem you mentioned, that's a religious poem. I mean, only God can make a tree.
At the end, but no, come on, the God was just in the culture. So
Okay.
is it religious when you say goodbye, when that draws from God be with you? It's just a cultural expression.
Think of Carl Sagan's chapter headings. They inspire me, just every single one of his chapter headings.
Yes. His widow, who is highly literate unto herself and co-author of all three cosmoses, even the two that I had the privilege of hosting. She was a major force in that poetic voice. I just want to give credit where that's due there.
Across the backbone of night. I mean, that is a poetic phrase. It immediately speaks to me. I see the Milky Way. I'm not sure I meant to. And I guess I try to do something similar, at least in some of my books.
The Ancestor's Tale. That is a title that reminds me of the Sagan book, Shadows of Forgotten Ancestors.
Yes.
It kind of feels the same to me. In what happened in Ancestor's Tale?
Well, it's a reference to Chaucer, the Canterbury Tales. And
But one of his tales was not the ancestor.
no.
Oh, you just,
It's
there's the Miller's tale and now the ancestor's tale.
It's a history of life, but it's going backwards. So it's in the form of a pilgrimage, a Chaucerian pilgrimage, going backwards in time. We human pilgrims set off into the past, and we're joined by the chimpanzee pilgrims and then the gorilla
brilliant.
pilgrims.
I
and
love that.
And then we finally get back to the origin of life. So it's a way of doing the history of life, but do it backwards. Because if you do it forwards, then you end up with the idea that humans are kind of the climax, which you don't want. I mean, that's not a good way of looking at it.
Here's one we all saw and know about, whether or not we read it, The God Delusion. That put you on a plateau to be identified as one of the four horsemen.
Oh, right.
It was bestowed upon you?
Yes.
Yeah, so it was Daniel Dennett, Christopher Hitchens,
Sam Harris.
and both of them are passed, Sam Harris and you.
Yes.
Okay. The four horsemen who have each been quite vocal about their atheism.
Yes.
And the God Delusion, if that's not atheist, I don't know what is.
It is, yes.
In the title.
Yes.
Right. So we spoke about this book before. Didn't you say there were religious groups that wanted people to read it so that they know the face of their enemy? Was that?
I forget. It's quite possible. There are some people who say they were converted to religion by it.
Really?
Yes.
So is this your single biggest selling book, The God Delusion?
Yes, just about. Yes,
Yeah.
or was equal to The Selfish Gene, maybe.
I've taken you to task on the very first day I met you, and I think it's worth repeating here. The first day I ever knew you. Again, like I said, I'd read your books, and I aspired to have the vocabulary, the command of vocabulary that spills off your plate. I took you to task in the front of a group. It was one of the what's the name of that conference? A Beyond Belief conference.
Oh, yes.
Which
Right.
gathered scientists,
Yeah.
biologists, theologians,
Yes.
philosophers.
Yes.
And it was to discuss, are we in an era beyond where belief matters?
Yes.
Does belief still matter?
Yes.
So it was quite the juxtaposition
Yeah.
of points of view. You and I are up on front in a panel. Two other people are there. And I heard you speak. I'd only ever read what you wrote. And I heard you speak. It was more articulate and more barbed than anything I'd ever read that you had written. And I said, oh my gosh, I'm glad we're on the same side, because if you had spoke to me, I'd feel like a complete idiot. I would feel not worthy of life. And then I thought, you are so potent. Is this turning people off because they reject it? Because you are not investing in how they think. Everybody has little receptors for receiving information. And if you're just going to say, I'm right, and I know I'm right, and you're all just wrong and you're idiots, maybe that's not as effective as you can be. So I challenged you to be a little more sensitive to people who are just trying to explore the world, and that you could be more effective than you are. The Greatest Show on Earth, 2009, subtitled The Evidence for Evolution. Was that motivated because around that time, there was the rise of what they called intelligent design?
Well, that had come before. I mean, this was, in a way, The Blind Watchmaker was a response to that.
Yes, of course.
But now this was really to set out the evidence for evolution, which I hadn't really done before. I just sort of assumed it. So,
I mean, assumed that everyone knew it.
well, not really. Well, yes, maybe.
Okay.
Yeah.
There's a lot of misunderstanding I have found. People think that an organism adapts to its environment. And I say, no, it either survives or dies. And there's a great quote at the end of War of the Worlds, where, as you remember, H.G. Wells, at the end, there's a recitation, and he says, I'm paraphrasing, he says, these creatures from another planet, they were doomed, undone by the smallest creatures on Earth, to which we had developed immunity.
Yes.
And it ends with a very poetic phrase, no man lives nor dies in vain. That through the toll of 1 billion deaths, man has bought his birthright on this earth, and it is his against all comers, and it would have still been his had the Martians been 10 times as mighty as they are, because no man lives nor dies in vain. And I thought that was potent. He was, of course, scientifically literate, and he's saying They're generations that die because they can't make it through this next stress to the environment.
It's rather horrifying when you think that actually that's what happened to the native South Americans when the Spanish arrived. I mean, they were killed by epidemics of things like measles, to which they had no immunity. And in Europe, they built up immunity to these diseases.
But the better analogy would have been had the South Americans wanted to invade Europe. They would have then died by the European diseases. Just a couple more books here. I'm skipping over like a half a dozen with your permission. One that I delighted, not only because I received a copy of it in the mail from your publisher, it was just delightfully done. Flights of Fancy, Defying Gravity by Design and Evolution. That was 2021. Beautiful book, illustrated. And who was the illustrator of that book?
Jana Lentsova. She's Slovak.
Just something that I think is underappreciated in this world, because we can't fly. So especially in the idea that we're at the top of the evolutionary scale and everything else is less than us. So just a celebration of flight in evolution. I was delighted by that.
Thank you.
And right now there's a book coming out called The Genetic Book of the Dead.
Yes.
A publisher actually let you use that title.
Why wouldn't they?
Because it's like, what?
I think it's rather an uplifting title. It doesn't mean human dead.
Does this have a subtitle? What's the subtitle?
Yes, it does have a subtitle, A Darwinian Reverie.
So tell me about this book. I haven't read it yet.
If you look at a highly camouflaged animal, a desert lizard, is one that I use. It's got pebbles and sand all over its back. It's just a dummy painting of a desert on its back. Okay, so that is a description of the world in which its ancestors lived. You can read that animal as a book describing the desert world in which its ancestors lived. Now, that's an easy example because it's got it painted on its back. But it must be true right the way through every cell of the animal, every molecule of the animal has got the same description written.
And some of it is baggage as in burdensome rather than...
Yes, but...
We have an appendix that can burst.
That's true.
You have a pinky toe. When was the last time you made good use of that?
Oh, you'd be surprised. The point is that natural selection is very, very fussy, is very, very intricate in its choice, far more than we even know about. We are poor judges of what's important for survival. When you think that the genes that survive, going back to the selfish gene, the genes that survive have to survive through lots and lots of different individuals and through a huge amount of geological time. And so any statistical estimate that you and I make about the likelihood that your pinky will be of any use to you is a statistical mistake. Natural selection is a much better statistician than we are.
So I'd need to think harder about my pinky toe.
Well, natural selection has millions of years in which to choose between successful toes and unsuccessful toes. J.B.S. Haldane did a calculation. J.B.S. Haldane, the great geneticist, did a calculation. He imagined a feature like a toe, something that seems trivial to you. And he said, let's allow that it's so trivial that for every 1,000 individuals who have it and survive, 999 die. This feature, the toe, whatever it is being repeated thousands of times in lots of different individuals and through lots of different millions of years. And it's got to survive through all those times. I'm explaining this very badly. The main point is that we are very bad estimators of what's important and natural selection is a much better estimator of that.
Okay, how about male pattern baldness?
That's a variable. I mean, some people have it and some people don't. You might take another example, maybe fingerprints. Why do we have fingerprints? Well, the fact that they're different doesn't matter, but are they important for clinging onto the trees when we had our boreal ancestors, that kind of thing?
Oh, I see. So even if they're not useful now, they were useful to get us to where we are now.
Hence the genetic book of the dead. I mean, we're talking about the past.
Damn, you're right. There it is. The genetic book of the dead.
Yes.
Enabling us to get to where we are at all.
Yes. We are a description of the worlds in which our dead ancestors survived. We are only here because our ancestors survived long enough to reproduce.
Yes.
And they survived because of the highly detailed features that they had, which their rivals
think differently about my pinky toe. Because without the pinky toe, there might have been some dead ancestor that would have ended that branch of the tree of life, and we would have never been here.
That's right, yes. Yeah.
Do you have hope for civilization as it's currently manifested in the world?
I think we have to have hope to live our lives at all. It doesn't mean that at an intellectual level I necessarily have but I live my life as though I have hope, yes. I've
become, cynical is not the right word. I've become a practical cynic. There are people who think this way or feel that way or behave this other way. And I've stopped trying to change them. What I try to do is offer a way of looking at the world that maybe they'll take, maybe they won't. Maybe as an educator, it's my job to make this as tasty as possible. So that, hey, that's a good idea. I never thought about it that way. But otherwise, I just gave a presentation to a Christian school, K through 12. I talked about optics. And at the end, it was open Q&A, and they were 11th graders. And they started grilling me on science versus the Bible. And I said, I'm not here to stop you from being religious at all. Okay, we live in a country that protects your freedom to be religious, and you're in a private school. So the government is not going to come after you and say you have to get this out of the public coffers. I made that clear, but I didn't have the urge to try to convert them. And I get the sense that you've had this urge your entire life to convert people with no less zeal than a religious person, a religious evangelical religious person would have trying to convert people who are not that. Did I tell you? I didn't tell you this. We have a Big Bang Theater here.
Yes.
And back when we first opened here at the Hayden Planetarium, there's a separate theater space where we just talk about the Big Bang. Someone came out of the Big Bang, saw me and says, how come you didn't mention God in there? And then I realized, okay, what am I going to do? I say, how about this? Why don't you go to our Hall of Human Evolution and then come back here? That's way more offensive to them, having monkeys and humans hold hands in the dioramas than anything we could ever say in the Big Bang here.
I thought they'd rather like the Big Bang. I mean, the Big Bang sounds pretty much like Genesis.
It's a creation event. Yeah. Yes. Maybe that's why they thought we should have mentioned God and didn't. But I don't even have the conversation. I just send them over to your part of the museum.
Yes. But I think you're being too pusillanimous. You shouldn't duck the question.
Well, I don't duck it so much as sometimes I don't have the energy.
Oh, that's different. But in my field, that really is an absolute opposition. It's not something you
complete. Although the Catholic Church, they've met you in the middle.
Yeah, they have.
They said, we have this branch of primates, and then God breathed the soul into them, and they're humans, allowing evolution all up to that point.
Yeah. But
the world is not that binary. It's not that binary. I don't see it that way. There are religious people where Jesus is their savior, but they're perfectly fine with a 4.5 billion year old Earth.
Yes, they are.
Okay, they're not at the extreme.
They don't see the contradiction, but yes.
So maybe the plurality of the world is a feature rather than a bug of the programming of what it is to be human.
But the truth is so much more grand and so much more elegant and so much more poetic and so much more beautiful.
You could get more of that across if people didn't feel stupid talking to you.
Yeah, that's true.
So you're a professor at Oxford? Are you retired? Yeah. You retired. Okay. And you were professor of?
Public Understanding of Science.
Yes, I remembered that. That was a post created by
Charles Simoni.
To Charles Simoni, yes. And he created multiples of those around the world. That wasn't the only one.
No, he wanted the Princeton Advanced.
Yeah, the Institute for Advanced Study,
Yeah,
maybe?
that's right.
Okay.
Yes, I think that was in a different field. I think that was.
Oh,
that was,
okay. Okay. But it's interesting.
He's a very generous.
Yeah, if you're
philanthropist.
wealthy and you want to make a change in the world,
Yes.
that's a way to sort of keep that
Right,
going.
absolutely, yeah.
Right. And there's another professorship somewhere in the UK, a professorship of the public understanding of risk.
Oh, that's good.
That's a professorship. And forgive me, I don't remember where, but I know that exists.
Yes, that's good.
And people have no way to judge or to think about that as a challenge in their lives. Well, Richard, it's been a delight
As always, thank you so much.
have you
Neil.
here. Let me just end this with some brief reflections. Those among us who are educated on a level where you can't just hold it in, you have to sort of share the knowledge, wisdom, insights one gleans from having committed your life to studying a subject and its related components. And Richard Dawkins is an example of that. Carl Sagan used to say, when you're in love, you want to tell the world. And were there 24 books on this list that I just read? This is Professor Dawkins can't contain his love. And he's got to share it for all those who seek a deeper understanding of life. Not only their own lives, but the lives of everyone around them, and the lives of all that came before us, and the lives of all those yet to be born. But in there are messages of protecting our civilization, because without it, there will be no future lives to be born. And then what of our branch in the tree of life? That is a cosmic perspective. Neil deGrasse Tyson here, your personal astrophysicist. As always, I bid you to keep looking up.